Physics Major 2016, Paper 12. Question 17. A boy on a bicycle starts from rest and rolls down an inclined hill at 30 degrees to the horizontal. The boy and bicycle have a combined mass of 25 kg. There is a frictional force of 30 Newton which is independent of the velocity of the bicycle. What is the kinetic energy of the boy and the bicycle after rolling 20 meters down the slope? As you can see, there is a slope which is inclined by 30 degrees to the horizontal. So this theta is 30 degrees in this case. The boy and the bicycle, they have a combined mass of 25 kg. So if you consider this object to be the boy and the bicycle, there is 25 kg mass. There is a weight which will act vertically downwards. So weight acts vertically downwards. Then reaction force will act perpendicular to the surface. So you can see reaction force act perpendicular to the surface. If it's a rolling down, the friction force will act opposite to the motion. So the friction force is in this way, which is already given 30 Newton. It is independent to the velocity of the bicycle. Now we have to find the kinetic energy of the boy in the bicycle after rolling 20 meters down the slope. So we have to know something. If you have weight acting vertically downwards, the weight can have two components. So one is this way and one is along this direction. So if you consider this as a triangle, right angle triangle, this is going to be 90 minus theta. So this angle is going to be 90 minus theta. So this is going to be theta. So when you resolve the weight with the angle, you will have W cos theta. And away from the angle, when you resolve it, you will get W sine theta. So the downward force is W sine theta. So if you consider the resultant force along this slanted surface, it's going to be like this. The resultant force is written as ma, mass into acceleration. It's rolling downwards, which is W sine theta. W means weight, which is mg sine theta, minus friction. Friction acts on the opposite direction to the motion. So we have mass, the combined mass is 25 kg. G is 9.81, sine theta is 30 degrees, minus the friction force is given as 30 Newton, is equal to ma. So when you find the value of ma, you get it as 92.6. Next, what you do, you need to find the kinetic energy. Kinetic energy is a work done. So you can use this formula, work done, which is the energy transferred to kinetic energy, which is F into D. Work done is force into distance, but we know our resultant force is 92.6. Already it's found. So take 92.6 Newton, multiply by the distance it's going to roll. It's going to roll 20 meters. So into 20, we'll get 1852 joule. As you can observe the choice, the option is A. Question 18. An escalator in an underground station has 250 people standing on it, and it moves with a velocity 4.3 meters per second. The average mass of a person is 78 kg, and the angle of the escalator to the horizontal is 40 degrees. So you can observe there is an escalator. The angle the escalator is slanted to the horizontal is 40 degrees. It's moving with a constant velocity 4.3 meters per second. Per person, average mass of one person is considered to be 78 kg, but there are 250 people traveling on it. What is the minimum power required to lift these people? So we need to find the power, the minimum power required to lift 250 people in an escalator. You can see here, we know that the weight acts downwards like the previous question. The slant, this way you have mg sine theta. Since it's moving with a constant velocity, the resultant force should be 0. When will the resultant force will be 0? When the upward force is equal to the downward force. So we already know the downward force is mg sine theta, which will be also equal to the upward force. So our upward force is mg sine theta. Mass of 250 people, that will be 250 into 78. Then to find their weight, multiply by 9.81 into sine theta is 40 degree. So we'll get the Newton as 12,000. It's going to be 122,962 Newton. So this is the force. To find the power, power is equal to force into velocity. So in case if you don't know, power means it's work done over time. Work done means force into distance over time. So if you consider distance over time, that becomes velocity. So you can also use this. So we already found the force to be 120,962 into the constant velocity, that's 4.3 meter per second. Therefore, the answer is 530,000 watt or 530 kilowatt, which is your option C. Question 19. An electric motor operating a lift has an output power of 20,000 kilowatt. The lift and passengers have a combined mass of 1,500 kg. The motor raises the lift through a distance 20 meters. How long does it take? So this power, the output power is the useful power. This power is used to lift 1,500 kg upwards. So we already know that power is equal to energy over time. So basically this energy is the gravitational potential energy because it is raising up vertically through a distance of 20 meters. So what we can do is first find the energy, make energy as the subject, so power into time. This is going to be equal to the gravitational potential energy, which is mgh. Substitute all the values, make time as the subject. So place of mass, we have 1,500, g is 9.81, the height that is going to lift through is 20 meters, divided by the power is 20 kilowatt. Kilo is a prefix for 10 to the power 3. So 20 into 10 to the power 3. When you calculate it, you'll get it as 14.7, which is very close to 15 seconds. Therefore, the option for this question is B. Question 20. A spring balance consists of a spring of length 20 centimeters with a hook attached. When a fish of mass 3 kg is suspended from the hook, the new length of the spring is 27 centimeters. So initially the length is 20 centimeters. When you hang a fish which is of 3 kg, there is an extension of 7 centimeters. What is the spring constant? So we know that formula from the Hooke's law, F is equal to spring constant into extension, making K as the subject, which is the spring constant, that is force over extension. Force 3 kg, weight, so 3 into 9.81, that will give you the weight, which is the force downwards. Extension is by 7 centimeters, centi is a prefix 10 to the power minus 2. So we get the answer as 420 Newton per meter, which is option D. Question 21. A metal wire is attached to one end to a fixed point and a load is hung from the other end, so the wire hangs vertically. The load is increased from 0 to 20 Newton. This causes the wire to extend elastically by 5 centimeters. So when you keep updating the load of 20 Newton, there is an extension of 5 centimeters. Now, if you reduce it to 12 Newton, the extension decreases to 3 Newton. So first, initially, you're keeping a load of 20 Newton. You observe the extension at 5 millimeter. And once you reduce the load to 12 Newton, the extension now is 3 millimeter. How much strain energy is released during the unloading process? So when you're loading, you're going to gain this much of strain energy, that is the area under the load extension graph. And when you return back to this position, only this much is stored. So this amount, this particular amount is being released during unloading. That is the area of this trapezium. So you need to find the area of the trapezium to find the strain energy released during unloading. So we know that the trapezium is half into the sum of the parallel line into the vertical height. So we have a vertical parallel line. This is 12 and this is 20. So half into 12 plus 20, and the height is this one. The distance between the perpendicular distance between two parallel lines. So 3 to 5, which is 2 millimeters. So 2 into 10 to the power minus 3. We get the option as 3.2 10 to the power minus 2 Joule. So you can see the answer is option D. Question 22. A microphone connected to the Y plate of the cathode ray oscilloscope is placed in front of a loudspeaker. The trace on the screen of the CRO is shown. So we have observed that this is the trace on the screen. Time base setting is 0.5 millisecond per centimeter. Time base means the time per division is 0.5 millisecond. And Y plate sensitivity is 0.2 millivolt per centimeter. That means on the Y-axis, you will get millivolt for 1 centimeter. What is the frequency of the sound from the loudspeaker, and what is the amplitude of the trace on the CRO? So you can see, if you want to find the time period first, you need to find the number of division horizontally for one complete wave. So for example, let me take this point to this point is half wave. So if you want to take from half wave, you have 1 division 1 centimeter, 2 centimeter, 3 centimeter. 3 centimeter is for half wave. So for one full wave, you will have 6 centimeter. So number of division for one wave, one complete oscillation is 6 centimeter, multiplied by the time base 0.5 millisecond per centimeter will give you 3 millisecond. So time period means the time required by one complete wave. So for one full wavelength, the time is 3 millisecond. Reciprocal of time period will be frequency. So 3 millisecond means 3 into 10 to the power minus 3. We get our answer as 333.3 hertz. So when you round it off, it's somewhat like 330. Now to find the amplitude, you need to find the vertical height. So as you can see, the maximum point is here, the minimum point is here, which is 1, 2, 3, 4, 5, 6. So the equilibrium position is the midway. From here, your amplitude is going to be, so this is your equilibrium position, where the displacement is considered to be 0. Maximum displacement is considered to be the amplitude. So there is 3 division, 1, 2, and 3. So 3 centimeter is your amplitude, but should be in terms of millivolt. So you're going to have 3 centimeter into your Y plate sensitivity, which is 0.2 millivolt per centimeter. So when you multiply, you'll get 0.6 millivolt. Frequency is 330. As you can see, frequency 330, amplitude in millivolt is 0.6. Therefore, the option is answer A. Question 23. A source of sound of frequency 100 Hz moves away from a stationary observer at a speed of 30.0 meter per second. The speed of the sound is 330 meter per second. What is the frequency of the sound heard by the observer? Okay, so this is about Doppler's effect. The object is moving away from the observer, so that's a redshift. So in that case, you have to use this formula. The observed frequency is equal to the velocity, or you can use the final velocity. You can use this one. Observed frequency is equal to frequency of the source into the velocity of the medium divided by the sum of both the velocity. So we have 1000 as the frequency. Sorry about it. Yeah, we have 1000 as the frequency of the source of sound having a frequency is 1000 hertz. Then in place of velocity of the medium, that's 330, divided by the velocity of a medium is 330, and the velocity of the source, that is 30.0. So you'll get your answer as 917 hertz. This is for an object that is moving away from the observer. So basically you can see there is an increase in wavelength. That is when to an observer, the frequency, the wavelength will seem to be longer. So that's what you can see. These values are increased. This is the stationary observer. When something is moving away, which is the red shift, the wavelength will seem to be increased. When something is moving, if the observer is here, then you will feel the wavelength is shorter. So this formula you can only use if it is for an object moving away. And if it's negative, this part is negative, then it's for an object moving towards the observer. So answer for this question is 917 hertz, which is B. Question 24. Each of the principal radiation of the electromagnetic spectrum has a range of wavelength. Which wavelength is correctly linked to its radiation? So as you can see, the spectrum, you'll have increasing wavelength, decreasing frequency. So you need to remember for radio wave, the order of the power, order of 10 is 3, microwave 10 to the power minus 2, infrared 10 to the power minus 5, visible 10 to the power minus 6, ultraviolet it's around 10 to the power minus 8, X-ray it's 10 to the power minus 10, gamma ray 10 to the power minus 12. So if you move this way, the wavelength is increasing, but you can see the frequency is decreasing. So radio wave has the greatest wavelength, whereas least frequency. So gamma ray, if you observe gamma, it is somewhere around 10 to the power minus 12. So the option, this one is not correct. Microwave, it's 10 to the power minus 2. So again, it's 10 to the power minus 5, which is incorrect. Ultraviolet, 10 to the power minus 8. This should be correct. X-ray 10 to the power minus 12. That's completely wrong. So the correct answer is option C. Question 25. A stationary wave is set up on stretched string. The diagram shows two instants of time when it has maximum displacement. The oscillation of point P on the string has an amplitude A. What is the distance moved by P from the position shown in the diagram after a half time period of the wave? Half time period means half of the wave. So if you consider P here, one complete wave ends here. If it's half wave, it ends here. So for the point P to move to this point, what's displacement or what's the distance it has to move? So if you take the equilibrium position to be in the midway, from this point to go here vertically, P has to move amplitude A. And from here to reach vertically to this place, it has to reach another A. So basically from this point to this point, if it has to reach from the lower end to the maximum point, it has to first come A, that's the amplitude, that is to the equilibrium, and another A to go to the topmost. So it has to move to A. Therefore, you can see the answer for this question is option C. If you like this video, please subscribe to my channel and press the bell button to get notified with new videos.